Yes. Okay. Can you do you like that? Do you actually?
Yes, sir.
I bet it's I would just.
I'll put this in.
Yeah. Starting. Yes. Good evening, students. The last class we discussed about important long answers in chemical bonding. Continuation of that, we go for the one or two or questions are there regarding long answers. Now see the first long answer question. See the first long answer question, that is give molecular orbital energy diagram of what? N2 gas and O2 gas. Calculate respective bond order and magnetic nature of what? N2 gas, comma O2 gas. One of the beautiful questions, students. Understood this question? Now see, molecular orbital energy diagram of what? N2 gas. That is the very simple diagram. Now see the diagram. With respect to the N2 gas, you take N2 gas. N2 gas atomic number is what? 7 electrons into 2. That is equal to 14 electrons. For 14 electrons, what is the sequence you write, students? The sequence you write like this: 1s sigma, 1s sigma star. Okay, one now the excellent question: 2s sigma, 2s sigma star. Right? Now you write 2px pi. 2px pi is equal to 2py pi and 2pz sigma. Next you write 2px pi star is equal to 2py pi star, and you write what, Nana? 2pz sigma star, like that. Now tell me, this is the increasing order of energy of what? Molecular orbitals. Increasing order of what? This is the increasing order of energy of what? Increasing order of energy of molecular orbitals. Nice. Now basing on this, so 1s sigma is a what? 1s sigma is a bonding molecular orbital. 1s sigma star is a anti-bonding molecular orbital. What I am saying, students? 1s sigma is a bonding molecular orbital. 1s sigma star is a anti-bonding. Because of the 1s bonding, it can fill up what? Bonding molecular orbital is filling up 2 electrons, again filling up the 2 electrons, again filled with 2 electrons, again filled with 2 electrons. Because of the equal symbol, these bonding molecular orbitals having similar amount of energies. Because of the equal sign, 2px pi have the same energy of what? 2py pi. Therefore, 8 completed. So because of the equal sign, you can apply the Hund's rule here. What is Hund's rule? Each molecular orbital is filled with a single electron with the same spin. Later pairing takes place with what? Pairing takes place with opposite spin, like that. Now tell me, totally 12 electrons are completed. Again, 2pz sigma having 2 electrons, because single molecular orbital accommodate 2 electrons. What I am saying? Single molecular bonding orbital accommodate how many electrons, students? 2 electrons. So here, because of the equal sign, we can apply the Hund's rule. What is Hund's rule? Each bonding molecular orbital is filled with single electron. Later pairing starts with what? Later pairing starts with opposite spin. Now, one simple formula is there for bond order calculation. Now, bond order in given molecule, bond order in the given N2 gas molecule is equal to half into what you write? Half into bonding electrons. What you write, Nana? Half into bonding electrons minus anti-bonding electrons is the simple formula, students. Half into what is the formula? Half into bonding electrons minus anti-bonding electrons. Now, basing on that, half into, tell me, bonding means what? Without star. Anti-bonding means with star. So, bonding electrons are how many are there? 2, 4, 6, 8, 10. 10 electrons are available in the bonding molecular orbital. In the anti-bonding, how many electrons are available? 4 electrons are available. That becomes half into 6. That is equal to bond order is 3. In the N2 gas, the bond order is how much, students? In the N2 gas, the bond order is 3. That means bond order 3 means what? The N2 gas, simple logic, N2 gas exists as what? N2 gas exists as N triple bond N. You write like that. And the next one, in the question, what is asking? Magnetic nature. Here, this is 2 electrons, no unpaired electrons. 2 means what? One is plus of spin, one is minus of. 2 means what? One is plus of, one is minus of. That means there is no unpaired electrons. Due to absence of unpaired electrons, what I am saying, due to absence of what? Due to absence of the unpaired electrons. So here this is the N2 gas is diamantic nature. N2 gas is what nature? Diamantic nature. One of the important bit. Repeat a bit once again. Why the N2 gas is diamantic nature? Simple logic. Because in the N2 gas there is no unpaired electrons. Because of unpaired electrons, it is diamantic nature. Now it can explain as a diagrammatically. First you write like this because the 8 marks question. First you write like this. Now you go for the diagrammatically. How you write diagram of this N2 gas? Simple logic, Nana. You write like this. This is the increasing order of what? Increasing order of the energy. Right, students? Very good. Now this is what, student? Nitrogen atom. Yes, nitrogen atom is what you write. This is 1s2. This is 2s2, and what you write? 2p3. 2p3 means what? 2px1, 2py1, 2pz1. The atomic orbitals having similar amount of energies. And in the N2 gas, we take the second nitrogen atom. For second nitrogen atom, again what you write? You write 1s2, and what you write? You write as 2s2, and you write here 2px1, 2py1, 2pz1, like that. Understood? Now, this nitrogen atom of the atomic orbitals, this nitrogen atom of the atomic orbitals, both are combined, gives rise to what? Gives rise to molecular orbital. In the molecular orbital, you get bonding as well as what? You get bonding as well as anti-bonding. Now you get 1s sigma bonding. This is called what? 1s sigma bonding, molecular orbital, and this is called what? 1s sigma anti-bonding. Anti-bonding shown by the star symbol. Here you can fill the 2 electrons. Now you can fill the 2 electrons. Very easy explanation, students. No confusion. Again, the 2s2 of the first atom combined with 2s2 of the second atom, and again what you get? Again you get 2s sigma bonding and 2s sigma anti-bonding. What you get, students? So this is called what? 2s sigma bonding and 2s sigma anti-bonding. Understand what I am saying? Now this is what? 2s sigma bonding having 2 electrons are filled up, and 2s sigma anti-bonding, again 2 electrons are filled up. Now here, now 2px, 2py, 2pz, that means p subshell having 3 atomic orbitals are combined themselves, and you get like this. How you get like this? Here you get, see, now here you get like this. Now see, again you get like this. No need of the above part. So you write like this. So this is what, Nana? This is 2px pi is equal to 2py pi. This is what? 2pz sigma. Understood? Simple logic. As per the diagram I am writing now. So as per diagram I am writing 2px pi is equal to 2py pi. So basing on that. So 1, 2, 3, 4, 5, 6. You can write like this. This is the diagram of what? Molecular orbital diagram of what? N2 gas with respect to what? With respect to increasing order of energy. With respect to what, students? Increasing order of the energy. Understand the point what I am saying? So this is the 2px pi equal to py pi. Now you write 2pz sigma. Therefore, so this is the constant we can apply. So bond order in N2 gas equal half into bonding electrons minus anti-bonding electrons. The bond order comes as 3. Therefore, N2 gas exists as what? N2 gas exists as N triple bond N. Understand? Simple logic, students. No confusion, Nitish. Anush, clear? Teja, clear? Yes, very easy concept. And the next example, go for the next example. So, the molecular orbital diagram of what? O2 gas. Again, the same explanation for the O2 gas. See, for the O2 gas, what you write? For the O2 gas, oxygen atomic number is what? 8. That means what you write? 8 electrons into 2. That is equal to 16 electrons. From that, what you write? Increasing order of energy. 1s sigma star, right? 2s sigma star. And next, what you write? 2pz sigma 2px pi is equal to 2py pi. right? Now what you write again? 2px pi star is equal to 2py pi star, and you get 2pz sigma star. In case of the water gas, the 2pz comes front side. Why the 2pz writing and the front side means that comes from the objective part. For IPE classes, no need to why the 2pz write first. No need to explanation of that. Now for the O2 gas, now tell me, 16 electrons are there. So one is sigma filling up 2 electrons. One is sigma star means anti-bonding filling up 2 electrons, filling up the 2, filling up the 2. This is 2pz sigma bonding molecular after filling up the 2 electrons. Totally 10 electrons are completed. Because this is what increasing order of what? Increasing order of energy of molecular atoms. Increasing order of what? Energy of the given molecular atoms, like that. Now, because of the equal sign, we can apply the Hund's rule. According to Hund's rule, each molecular atom is filled with a single electron. Later pairing starts with opposite spin. 10 completed. Now 11, 12, and you get what? 13, 14. After then you get 15 and 16. What you get, Nana? 15 and 16, like that. Therefore, what is the formula for bond order? Therefore, the formula for bond order is equal, what you write? Half into bonding electrons. What I am saying? Half into bonding electrons minus anti-bonding electrons. What is the formula you write, students? Half into bonding electrons minus anti-bonding electrons. That is equal half into. Tell me, what are the bonding electrons? So this is one is sigma is a bonding. How many bonding electrons are there? 2, 4, 6, 8, 10. So bonding electrons are 10, Nitish. And anti-bonding electrons are what? 6 anti-bonding electrons are there. Therefore, half into 4 is equal to 2. So therefore, bond order is 2. Bond order 2 means what you write? O2 gas. You write like this. O2 gas exists as O double bond 4. And next one we ask about what? Magnetic nature. Come to the magnetic nature of this O2 gas. Now see, the 2px pi star anti-bonding. The 2py pi star anti-bonding have single unpair is there. And what is that? Single unpair is there. Therefore, so in the anti-bonding, what I am saying? In anti-bonding molecular orbital, 2 unpaired electrons are present. Because of the 2 unpaired electrons are present, so it is paramagnetic nature, one of the excellent point. Therefore, the O2 gas is what nature, students? The O2 gas is paramagnetic nature. What is the formula for magnetic moment? Mu means what? Mu means magnetic moment. So what is the formula for magnetic moment? Mu is equal root over n into n plus 2 bm. What is the formula? Root over n into n plus 2 bm. That means what you get? Root 8. Root 8 means what? 2 root 2 bm you got. Now that is equal what you get? 2 into 1.414. That is equal 2.88 both magnetons. What is the answer? 2.2 both magnetons. That's clear what I am saying? Yes. Jane, what is your doubt, Nana? So these are the IPE classes, for pre-classes, what you are asking, Nana? When a acid present in epoxide react with nucleophile at least indirect carbon, most indirect, their general least indirect carbon is attacking. That is called Baeyer-Villiger oxidation. That reaction is called what? Baeyer-Villiger oxidation. Don't waste your time, Nana, because we are explaining IPE classes, free public live. So you want to ask the doubts, okay, and you join in the Roost Academy. You give all doubts clarification. Your posting one is a Baeyer-Villiger oxidation. You are a good subject student, but most students benefit this, right? Now, therefore, what is the formula for magnetic moment? The magnetic moment value is what? That is 2.828 bm. So this is the explanation of what? O2 gas. And you write the diagram, same like that, N2 gas diagram. Okay, so this is the explanation of the one of the 8 marks question for chemical bonding. One of the beautiful essay question for chemical bonding. Understood what I am saying? Yes. And see the next question. So see the one of the important again 8 marks question. Explain the factors favorable for formation of what? Favorable conditions for the formation of the ionic compounds. First of all, what is the meaning of ionic bond? Ionic bond means, simple statement is there. Ionic bond means a strong electrostatic. What I am saying, a strong electrostatic force of attractions. A strong electrostatic forces of attractions. A strong electrostatic force of attractions developed. A strong electrostatic force of attractions are developed between the cation and anion. Between the what? Cation and anion is known as what? Ionic bond. This ionic bond is what? This ionic bond is a non-directional nature. Because of attraction, the ionic bond is what nature? This ionic bond is non-directional. This ionic bond is what nature? Non-directional nature. One of the excellent important point. Understood what I am saying? Repeat the statement once again, students. Ionic bond means what? A strong electrostatic force of attractions developed between the what? Cation and anion. Okay, that is the meaning of ionic bond. So this ionic bond is what directional nature? Is a non-directional nature. Why this is called non-directional nature? Because of no overlapping of orbitals. Covalent bonds are directional nature because of the overlapping of the orbitals. But ionic bonds are what nature? Non-directional nature. And what are the favorable conditions for the ionic compounds formation? First of all, we see for the ionic compound formation, we require favorable conditions for the metal. We discuss about favorable conditions. Favorable conditions of the cation. Actually, the cation is coming from what? The cation is coming from the metal atom, yes or no? So this is the important favorable conditions for the cation. What is the first favorable condition? So big size. The first point is what we write as a point wise. Bigger size of the metal atom required. What I am saying, bigger size of the metal atom is required. If the metal atom is the bigger size, the bigger size of metal atom has the least ionization energy value. What I am saying, students, because metal atom is the biggest size, is the least ionization energy value. And see the second point. The second point is what? The metal atom ready to lose electrons. Yes, Nana. So one line is the question you got, Nana. Nickel Bangalore. Yes, Nana. From chemical bonding, periodic classification, and from atomic structure, you have the one long answer, two long answers, and organic chemistry has the one long answer, right? Yes, Nana. So the metal atom, so ready to lose electron. The metal atom is ready to lose. The metal atom is ready to lose the electrons. The metal atom is ready to lose the electrons, and the next point is what? So, reducing nature of the metal atom should be high. What is the meaning of reducing nature? Reducing nature of the metal atom. Reducing nature of what? Reducing nature of the metal atom should be what? The reducing nature of the metal atom should be high. What is the meaning of reducing nature? The metal atom ready to lose electron should be high. So these are the favorable conditions. Now all these conditions I am satisfied with what? Satisfied with the 1A group metals. Satisfied with what, Nana? 1A group metals. So what are the examples of the 1A group metals? The 1A group metals are lithium, sodium, potassium, rubidium, cesium. Now see, this is the size of the lithium, size of the sodium, size of the potassium, size of the rubidium, and size of the cesium. So bigger size of the metal atom required. Cesium is the big size. Because of big size, the nuclear force on the valence shell is less. Nuclear force on the valence shell is what? Less. As nuclear force on the valence shell is less, least energy is required for cesium. The cesium ready to lose electron. Now the metal atom ready to lose electrons because of big size. Reducing nature of the metal atom increases down the group. Because the cesium metal atom itself is a big size, students. Because cesium metal atom itself is a what? Big size. So the easily lose of electrons happen. That is the meaning of what? Reducing nature of the metal atom. That means the cesium metal atom. The cesium metal atom ready to lose the valency electron forms cesium cation. That property is called what? That property is called oxidation. Loss of electron is called what? Oxidation. The species involved in oxidation is known as reductant. Reductant means what? Reducing agent. That is the favorable conditions of the given metal atom. Understood what I am saying? Yes, understood. Yes, Nana? And next we discuss about favorable conditions of what? Favorable conditions of the non-metal atom. Exactly reverse conditions are required. Now see, favorable conditions. Favorable conditions of non-metal atom. Favorable conditions of the non-metal atom. Now, what are the favorable conditions of the non-metal atom? First of all, regarding the favorable conditions, small size of non-metal atom is required. Small size of atom required. If the atom size is small, yes, if the atom size is small, so its electron affinity value is more. As I said in the last class, what is the meaning of electron affinity? Electron affinity means what? Electron acceptance nature. Its electron affinity, its electron affinity value should be more. Electron affinity value should be more. What is the meaning of electron affinity? Electron is added to the atom, amount of energy liberated. If the size of the atom is very small, its electron affinity is more. Why electron affinity is more? If the size of the atom is the small, nuclear force on the valence shell is more. Nuclear force on the valence shell is more. Nuclear force on the valence shell is more. Electron acceptance tendency is easy. Electron acceptance tendency is easy. That is the logic. What I am saying, if the size of the atom is very small size, so the nuclear force on the valence shell is more. The nuclear force on the valence shell is more, the electron acceptance tendency is more. That is the important point. And one of the important point is what? The non-metal atom with the highest EN value is required. Non-metal atom with what? Non-metal atom with the highest EN value is required. What is the EN value? EN value means again attraction of the electron nature. Attraction of what? Electron nature. So the non-metal atom with the highest EN value is required. By that, the non-metal atom should act as the best oxidant. The non-metal atom acts as what? The non-metal atom acts as best oxidant, easily reduced. What I am saying? The non-metal atom acts as best oxidant, easily reduced. Now take the example of the fluorine, example of the chlorine, example of the bromine, example of the iodine. You tell me, what is the general configuration of these halogens? The general configuration is NH2, NP5. In the valence shell, 7 electrons are there. Now fluorine is the small size. Because fluorine is the small size, this is the size of the fluorine, this is the size of the bromine, and this is the size of the iodine. Because the fluorine is the small size, the fluorine is ready to accepting electron in the gaseous state. What I am saying? The fluorine is ready to accepting electron and forms what? F minus ion. Now the gaining of electron by fluorine is called what? Electron affinity. Heat is liberated. So because of the small size of the fluorine, so its nuclear force on the valence shell is more. As nuclear force on the valence shell is more, so more amount of heat is liberated out. Now the acceptance of electrons is called what? Reduction. Now the species involved in reduction is known as, that's why the fluorine is acts as oxidant. The fluorine is acts as what? Oxidant. Because fluorine becomes what? Gaining of electron is called what? Students? Reduction. Now the species involved in reduction is known as what? Oxidant. That's why the fluorine acts as one of the strongest oxidizing agent, easily reduced to F minus ion. And this is the favorable conditions for the non-metal. Just you write the points like that, you get out of the 8 marks, out of the 8 marks. So these are the important essay questions from the chemical bonding. Clear what I am saying? And go to the next one, and go for the in chemical bonding. 2 marks questions are may also coming. In chemical bonding, 1 essay question, and 2 marks questions 2 are given or 1 is given. That's why as per the blueprint we discuss about 2 marks questions also. Repeat once again, from atomic structure only you got essay question. You don't get any 4 marks questions. And for the periodic class question, definitely you got essay question. Our 4 marks question as AB for the essay question. 4 marks question, 2 questions given as the essay question. In chemical bonding, 1 essay question, maybe 1 is very short or 2 very short. Understood what I am saying, students? Now we discuss about, as per the blueprint, we discuss about 2 marks questions also. Right. Now see that first question. What is octet rule? Simple logic. Octet rule means what? The atom in the given chemical reaction. The atom in the given simple statement. For 2 marks question, just to write a one statement, definitely you get full marks. But you write the statement perfectly without having any mistake. Now you get very short 2 marks out of 2 marks, very easy. But you write the statement perfectly without having any mistake. Understood, students? Very good. The atom in the given chemical reaction. The atom in the given chemical reaction attains noble gas configuration. Attains what? Attains noble gas configuration. See, what is noble gas configuration? NH2, NP6. Attains noble gas configuration by losing or by gaining. Understood, students? By gaining or by sharing of valency electrons. Sharing of what? Sharing of the valency electrons. Because the valence electrons are involved in the chemical reactions. It is known as what? It is known as octet principle, also called what? Octet rule. Repeat the statement once again what I am saying. Tell me. Because the atom is the very smallest species in the matter. Therefore, atom in the chemical reaction attains noble gas configuration of what? NH2, NP6 by losing or by gaining or by sharing of the valence electrons. That is called what? Octet principle. You write like this, definitely you get 2 marks out of the 2 marks. It's a perfect statement, right? And see the next one. So, which are the 2 ions, Ca plus 2, Zn plus 2, which is more stable? Excellent question, Anna. Now, we write the configuration of the calcium. Calcium atomic number 20. For 20, what you write? For 20, you write neon 10, right? 3s2, 3p6, okay? 3s2, 3p6, 4s2. Ca plus 2 means what? Loss of the 2 electrons. From that, what you write? Neon 10, 3s2, 3p6, 4s0. Yes or no? What is Ca plus 2? Loss of the 2 electrons from valency shell. What is Ca plus 2? Loss of the 2 electrons from the valency shell. And now, in the Ca plus 2 in the valency shell, how many electrons are there? In the Ca plus 2 in the valency shell, 8 electrons are there. Now, 8 electrons means what? In the valency shell, 8 electrons are present. That means Ca plus 2 stabilized by, because of 8 electrons are present, Ca plus 2 stabilized through noble gas configuration. Stabilized to what configuration, students? Noble gas configuration. Because plus 2 means loss of electrons from the 4s now. Now, 3s2, 3p6 has 8 electrons in the valence shell, stabilized to noble gas configuration. And come to the configuration of the zinc. Zinc atomic number 30. For 30, what you write? Neon 10, 3s2, 3p6, 3d10, 4s2. This is the configuration of the zinc. What is the meaning of Zn plus 2? Removal of the 2 electrons from the valency shell of the 4s. Now from that, what you get? Neon 10, 3s2, 3p6, 3d10. Now you tell me, in the valency shell, how many electrons are there? In Zn plus 2, the valency shell has 18 electrons present. 18 electrons is not a noble gas configuration. 18 electrons is called pseudo-noble gas configuration. Tell me, is a pseudo-noble gas configuration. Therefore, the cation with noble gas configuration is more stable than pseudo-noble gas configuration, like that. Simple statement, students. Now, how you write the statement? You write the statement like this. Ca plus 2 cation is more stable than Zn plus 2 cation because Ca plus 2 is stabilized by noble gas configuration, whereas Zn plus 2 is stabilized by the pseudo noble gas configuration. What is pseudo noble gas configuration? Presence of the 18 electrons in the valence shell. Presence of what? 8 electrons in the valence shell, that is called pseudo noble gas configuration. Understood the difference? One of the excellent statement. Repeat the statement once again, students. Ca plus 2 cation more stable than Zn plus 2 cation because Ca plus 2 cation is stabilized by noble gas configuration, whereas Zn plus 2 cation is stabilized by the pseudo noble gas configuration. In the bracket, you write presence of the 18 electrons. That's why Ca plus 2 n is more stable. You write like this. Definitely get 2 marks out of the 2 marks. Very easy, students. Chemistry is very easy, Nana. Not so much difficult. See the next IPE 2 marks question. Cl minus ion is more stable than what? Cl minus ion is more stable than chlorine atom. Why? Yes, you write the chlorine atom configuration, chlorine atomic number 17. For 17, what you write? Neon 10, 3s2, 3p5. Yes, now adding of the electron. When electron is added, now forms what? It forms Cl minus with liberation of what? Nearly 342 kilojoules per mole of energy. Why energy liberated? By addition of electron, it is stabilized by the noble gas configuration. Neon 10, 3s2, 3p6. Neon 10, 3s2, 3p6 means what? It is stabilized by the argon configuration. Stabilize what configuration, students? Argon configuration. That's why Cl minus ion is more stable than Cl atom because Cl minus is stabilized by argon configuration. Any species is stabilized by the configuration that is an exothermic nature. Exothermic nature means what? Amount of energy liberated. This statement is called electron gain enthalpy. The statement is called what, students? This is the statement of also called electron gain enthalpy. What is the symbol of electron gain enthalpy? Delta Hg. So this is the equation I am writing. What I am saying, students, is a 2 marks question. For 2 marks question, how you write? Cl minus ion more stable than Cl atom because Cl minus ion is stabilized by the noble gas configuration, whereas Cl don't have the noble gas configuration, and you write the equation like this. Repeat the equation once again. Repeat the statement once again. Cl minus ion is more stable than Cl atom because Cl minus ion stabilized by noble gas configuration of the argon, whereas Cl atom is not stabilized by the noble gas configuration. That is over. So this is the 2 marks question. Just to write the equation and write the statement. Definitely you got 2 marks out of 2 marks. Very easy. No confusion, students. And see next one. Why argon does not exist Ar2 molecule? Simple logic. Because the argon, what is the atomic number of argon? Atomic number of argon is 18. 18 means what you write? Neon 10, 3s2, 3p6. In the valence shell, electrons are completely filled up. So the valence shell is a completely filled configuration. The configuration is completely filled. It's a completely filled configuration. Because of completely filled configuration, argon gas not participated in chemical reaction. Not participated. Argon gas not participated in chemical reaction. Therefore, argon gas is not participated in chemical reaction. So therefore, Ar2 molecule not exist. Just you write like this. Now I said, how will you write the statement? So argon 18, the valence shell is completely filled configuration. Because of the completely filled configuration not participate in chemical reaction, therefore Ar2 molecule not exist. Ar2 molecule not exist. Repeat once again. Argon atomic number 18. The valence shell is a completely filled configuration not participated in chemical reaction. That's why Ar2 molecule not exist. Just you write like that. Just you write what? Like that. And go to the next IPE question. So 2 marks question, Nana. A comma B, 2 different atoms. right? A comma B are what? Two different atoms. When does AB molecule becomes a covalent? Simple logic. See, En value of the A atom and En value of the B atom, whose En difference, whose delta En value, tell me what I am saying. En value of A atom is there, En value of B atom is there, whose En difference value less than 1.7 to 1.9. What I am saying, less than 1.7 to 1.9. Now the molecule forms covalent bond. Now the molecule forms what? Molecule forms covalent bond. Yes, I am explaining with simple example. Take the example of H2S molecule. Take the example of students, H2S molecule. This is H2S molecule. En value of hydrogen 2.1. En value of hydrogen 2.1. Sulfur En value is 2.5. Now between these two atoms, the En difference is what? Difference of En is 0.4. Between these two atoms, En difference is what? En difference is 0.4. Difference means 2.5 minus 2.1. So it is less than 1.7 to 1.9. That's why H2S molecule is a pure covalent molecule. H2S is a what? Pure covalent molecule. One of the beautiful statement. How you write the statement? Whose difference of En value between two atoms? Tell me. Difference of En value between two atoms less than 1.7 to 1.9. Now the molecule forms what? Covalent bond. Example, H2S gas. In H2S gas, hydrogen En value 2.1. Sulfur En value is 2.5. The difference of En value is what? The difference of En value is 0.4. That is less than 1.7 to 1.9. That's why the H2S molecule forms a covalent molecule. Just to write like that is a 2 marks question. Just to write one statement, one example. Tell me students what I am saying. Just to write one statement and one example. Definitely you got the 4 marks, 2 marks. Understood what I am saying? So 2 marks question, you write the statement of an example, easy. Now see next one. Why H2O has higher boiling point than HF? Simple statement. See, in H2O molecule, see, simple logic. One H2O molecule able to form, simple statement. One H2O molecule able to form 4 hydrogen bonds. One of the beautiful question, this question given in the previous paper for very short, nearly 5 or 6 times. This question given in the previous papers, students, nearly 5 or 6 times. One H2O molecule able to form 4 hydrogen bonds with surrounded 4 water molecules. Understood? With surrounded 4 water molecules. And see next point, one HF molecule, what I am saying, one HF molecule able to form, tell me, one HF molecule able to form 2 hydrogen bonds. One HF molecule able to form 2 hydrogen bonds with the surrounded HF molecules. Simple logic, no confusion in the logic. Therefore, boiling point of H2O greater than boiling point of HF, because in H2O the hydrogen bonds are double the number of hydrogen bonds in the HF. See, one H2O able to form what, students? 4 hydrogen bonds. One HF molecule able to form how many bonds, students? 2 hydrogen bonds. That's why. So the number of hydrogen bonds in the water double to number of hydrogen bonds in the HF. There is a simple logic, no confusion in the logic. Understood? That's why H2O molecule has higher boiling point than HF molecule. And see the next question. What type of the bonds present in ammonium chloride? Simple logic, Nana. See, this is an ammonium chloride. Ammonia, NH3. So this is what? NH3 have a lone pair. The lone pair forms a what? Day2 bond with H plus dot Cl minus. So this is structure of what, students? Simple structure, student. The lone pair of nitrogen forms a what? Day2 bond with H plus dot Cl minus. Now here H plus Cl minus is there. Because of H plus and Cl minus, this is a plus minus is called an ionic bond. So ionic bond is present. Now itself it is a what bond? Itself it is a day2 bond. Day2 bond also called what? Coordinate covalent bond is called day2 bond, right? Now this is called what? This NH bond. Single bond always is sigma bond. The sigma bond nothing but what? Sigma bond nothing but a covalent bond. So this is structure of the ammonium chloride like this. In the structure of this ammonium chloride, so three kinds of bonds are available. The first bond is what, students? The first bond is ionic bond because of the positive charge and negative charge. So this is the symbol. Arrow mark is the symbol of the T2 bond like this. So NH bond is sigma bond is a covalent bond like this. So in this way, three kinds of bonds are available: ionic bond, T2 bond, and covalent bond, right? And see the next bit. Define bond angle and bond enthalpy. Yes, simple logical question. So how you define bond angle? So the bond angle defined as, this is the for 1 mark, this is for the 1 mark. A 2 marks question, definitely have the one or two marks question from chemical bonding students. Understood what I am saying? Please respond. Study task, Ganesh, JEE Bangalore, please respond. So what is the meaning of the bond angle? Bond angle means the angle present in between the angle present in between the bonded pair of, bond angle means the angle present in between the bonded pair of electrons, bonded pair of electrons of two bonded atoms of what? Two bonded atoms. Simple logic. Take the example of the one of the example. Take the example of H2O. In the example of H2O, this oxygen has a what? Lone pair. This oxygen has a lone pair. So this is a bonded atom. This is a what? Bond atom. In between the bonded atoms. Now what is the bond angle here? The bond angle is 104 degrees, 5 minutes like that. Take the example of the ammonia. The example of the ammonia is what? Just to write one example for 1 mark question. Now is a lone pair. Now this is a bonded atoms. Bond pair is a bond atom, bond pair. In between the bonded pair of electrons, the bond angle is 107. Write the example like that. That is the definition of the bond angle, students. Simple definition. So bond angle means what, students? The angle between the bonded pair of the electrons between the two bonded atoms of what? Of adjacent bonds. That is important, Nana. That is what? Adjacent bonds are same bond between the adjacent bonds. Is the adjacent bonds like that. Now how you define the bond enthalpy? That is very important. Bond enthalpy defined as, now see, bond enthalpy. The symbol taken as what? Delta H of the bond, the symbol of the bond enthalpy. Now the bond enthalpy defined as amount of energy required. What I am saying? Amount of energy required to break, amount of energy required to break the 1 mole of the bond, to break the what? 1 mole of the bond. Amount of energy required to break the 1 mole of the bond between the two bonded atoms of molecule. Two bonded atoms of what? Two bonded atoms of molecule. That is the meaning of bond enthalpy. Now basing on that bond enthalpy, so take the example of the H2 gas. So H2 gas on heating gives rise to what you get? We get H atom in the gas state, plus H atom in the gas state. That is called bond enthalpy. Amount of bond is required is plus 434 kilojoules per mole. You write the statement with one example. Definitely the examiner is very impressed. For the given statement, see Nana, in chemistry you get 60 out of the 60. 8 marks questions have no problems. 4 marks questions have no problems. But 2 marks questions, you make the more impressions to the student. You write the statement with one example of equation. If the equation example is there, better to write that example equation. Now the examiner is highly impressed and you get 60 out of 60. Because you get the best impression over the very short. Because the examiner starts the correction with the very short answers. Here the more impressed on the very short answers. Now the short answers of 4 marks, long answers of the 8 marks, they can overlook the questions, overlook the answer sheet. When you more impress the 2 marks questions by the statement, if equation is available, write the equation like that. Write the statement once again. How you said bond enthalpy? Bond enthalpy defined as amount of energy required to break 1 mole of the bond between the 2 bond atoms of the given molecule. One of the best example is what? H2 gas, the bond energy is 434 kilojoules per mole. Understood what I am saying? Very good. Now see next one. Define bond length and bond order. Yes, how you define the bond length? See, bond length defined as, bond length defined as half of the internuclear distance. What I am saying? Half of the internuclear distance between two bonded atoms of given molecule. Read the statement, Nana. How we define bond length, students? Half of the internuclear distance between 2 bonded atoms of the given molecule. For example, you take the example of H2 gas. So this is the H2 molecule. Is the nucleus of the first atom, is nucleus of the second atom. So this is what? This is the bond length. What is the exact bond length? 72 picometers. So what is right? So this is the bond length. That means what is the meaning of bond length? Half of the internuclear distance between the 2 bond atoms of given molecule is known as bond length. Simple statement. Also write like this. So also you write like this. No need of the half. The internuclear distance. How you write definition? So bond length is defined as the internuclear distance between the 2 bond atoms of a given molecule. One of the best example of the H2 molecule. In H2 molecule, the bond length is what? 72 picometers. Just to write like the internuclear distance between the 2 bonded atoms of a given molecule is known as what? Is known as bond length. Simple statement. Understood what I am saying? And come to the bond order. See, what's the meaning of the bond order? Simple logic. Bond order is defined as, but the statements most of the students don't know. You know you said bond order is 1, sir, bond order is 2, sir, bond order is 3, you said like that. But in the statement you don't know. How you define the statement of bond order? Bond order defined as the number of the bonds. What I am saying? The number of the bonds exist. Bond order defined as the number of the bonds exist between the 2 atoms of given molecule. Between what? 2 atoms of given molecule. That is the meaning of the bond order. Repeat the statement once again, students. So what is bond order? So bond order is defined as the number of the bonds exist between the what? The number of the bonds exist between the 2 atoms of a given molecule. 2 atoms of what, students? 2 atoms of a given molecule is called bond order. Take the example of the N2 gas. In N2 gas, wait one example. N2 gas bond order value is 3. How you know? Because N2 gas exists as N triple bond N gas and O2 gas. You know O2 gas? The O2 gas bond order is what? The O2 gas bond order is 2. How? O2 gas exists as O double bond O. And what is H2 gas? If example is there, to impress the examiner by the example. H2 gas is there, H2 gas bond is H single bond H. So here the N2 gas, the bond value is what? In N2 gas, the bond value is 3 because of 3 bonds. In O2 gas, the bond value is 2 because of 2 bonds. In H2 gas, the bond value is 1 because of the 1 bond, like that. Understood? This is the statement of the bond order. Repeat once again. So what is bond order? Bond order means what? Number of the bonds exists between the two atoms of the given molecule. Is called bond order. Yes. And see the next one. What is meant by localized orbitals? Simple statement, Nana. Localized orbitals are defined as, see, localized orbitals are defined as, simple statement, the electron density occupied over atomic orbitals, which are not participated in conjugation. Which are not what, students? Which are not participated in conjugation. That is the meaning of localized orbital. One of the best example is what? Pi orbital. Pi orbital is a localized orbital. Take the example, for example, take the example of pi bond. So this is a what, students? This is a sigma bond. Generally, the pi bond is formed by after the formation of what? Sigma bond. Yes or no? Now this is a pi bond representation like this. So this is a pi bond representation like this. This is what side? Positive side, negative side. Again is a positive side, is negative side. What is positive side? Positive side, negative side indicates what? Electron density occupation. Positive side, negative side explains what? Electron density occupation. Now, so this positive side is overlapping. This negative side is overlapping, forms a pi bond. That is the meaning of what? So the electron density is occupied over the atomic orbitals which are not involved in conjugation. That is called what? That is called localized orbitals. One of the best examples is what? Pi bond. So how can you show like this? It can also show like this. This is a sigma bond, students. Now this is the positive side. You can show like this, and negative side you can show like this. This is the same representation of the pi orbital. If this is correct, this is also correct. Positive side, positive overlap, and you get big positive side. Negative side overlap, you get negative big side. What is positive negative? Amplitude of electron density. What is positive negative, students? Amplitude of what? Electron density. Simple statement. That is the meaning of localized orbitals. That means electron density occupied over the atomic orbitals which are not involved in conjugation. Right. Now see next question. How many sigma bonds, how many pi bonds present in C2H2 and C2H4? Simple logic question. Carbon valency what? 4. 1, 2, 3, 4. Again, carbon valency how much? 1, 2, 3, 4, like that. Now C2H2. Now write sigma bond formation like this. And next bond formation is what? Next bond formation is a pi bond. Again, next bond formation is a pi bond, and this is a sigma bond formation. Like this, single bond is always a sigma bond. Therefore, in C2H2, 3 sigma bonds present and 2 pi bonds present. In C2H2, how many sigma bonds present? 3 sigma bonds present, 2 pi bonds present, right? And come to C2H4. So with respect to C2H4, so this is carbon valency is what, students? 4. And carbon valency is 4. What you write? C2H2. Now single bond is always sigma. Single bond is always sigma. Double bond means what? 1 sigma bond, 1 pi bond. Therefore here 5 sigma bonds present and 1 pi bond present. Tell me what I have said. 5 sigma bonds present and 1 pi bond present in the ethene gas. What gas? Gas name is called ethene gas. And this is called what gas? Ethane gas. Understood, students? Simple logic, no confusion. Array is a 2 marks question, students. To get the 2 marks, You write the structure like this, easily get the 2 marks. See, is one of the best academic objective of the IIT Advance and Mains NEET examinations. But for the sake of the students, to make the more benefit to the students, to do the free online classes is needed to change there in the campus. Now see, explain the hybridization involved in PCl5 molecule. Yes, simple explanation. Take the example of the phosphorus. Phosphorus atomic number is 15. For 15, what you write? Neon 3s2, neon 10, 3s1. Tell me, 3s1, 3bx1, 3by1, 3bz1, 3d1. Because in the first existed, I am writing. Where you am writing, Anna? Phosphorus in the first existed, I am writing 3s1, 3bx1, 3by1, 3bz1, 3d1. Now see, simple logic. 1 SR-tol, 3 PR-tols. 1 PR-tols are combined themselves and forms what? And forms 5sp3 dihybrid orbitals. Now the 5sp3 dihybrid orbitals having with single electron each. Having what, students? Single electron each and forms sp3 dehybridization like this. Now this is what you get. Phosphorus like this. You get the structure like this. PCl5 is a phosphorus having one of the sp3. Is a phosphorus having one of the sp3. sp3 have the dumbbell shape na. sp3 is one of the sp3 is one of the sp3 having single electron. It is head-on overlapping with what? Chlorine. The chlorine has what? 3pz. The chlorine has what? 3pz. Chlorine has what? 3pz. Chlorine has what? 3pz. 3pz electron, and you get sigma bond. Is a sigma bond. Is a sigma bond. Sigma bond. Sigma bond. Sigma bond. Structure of what? PCl5. The same structure is right like this. Very easy to simplify. Phosphorus, chlorine forms single bond, single bond, single bond, single bond, single bond. Now this is called axial bond. Now see, this is called equatorial. 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 This is called what? Axial. This is called what? Axial. The same structure. The bond angle is 90 and 120. But it's important for 4 marks, not for IPE 2 marks question. It's important for 4 marks question. So this is what? Trigonal bipyramidal geometry. Tell me. Trigonal. The geometry is called trigonal bipyramidal geometry. Simple explanation. You write like this. Yes, it's very easy, students. Understood what I am saying? In the first check, instead of phosphorus, what you write? 3s1, 3px1, 3py1, 3pz1, 3d1. Now the phosphorus having 1 s-tol, 3 p-tols, 1 d-tol, head-on combining themselves, head-on overlapping themselves forms 5 sp3 hybrid with single electron each. These 5 sp3 dihybrid head-on overlapping with pz orbitals of the surrounded chlorine atoms and forms 5 sigma bonds, and you get sp3 dehybridization. Now see, next one is very important. It's a 2 marks question. Even though nitrogen in ammonia sp3 hybridization bond angle deviates from the 109 degrees 28 minutes explained. Simple logic. So actually in the ammonia, so it's one of the important 2 marks question. In the ammonia, nitrogen has a lone pair because of the 5th group element na students. Because of what element? 5th group element. Understood what I am saying? Now, here because the nitrogen, one of the sp3 hybrid atom. Tell me what I am saying. One of the sp3 dihybrid, one of the sp3 hybrid orbital has a what? One of the sp3 hybrid orbital has a lone pair. Now this lone pair occupies what? The lone pair occupies more space. Lone pair occupies what? What is lone pair? Pair not involving bonding. Therefore, lone pair occupies more space. As lone pair occupies the more space, because the lone pair bond pair repulsions. Due to what, students? Due to lone pair. Repeat once again. Due to lone pair bond pair repulsions. Simple statement you write like this. Due to what? Lone pair bond pair repulsions. The bond angle deviated. The bond angle deviates deviated from 109 degrees 28 minutes to 107 degrees. Simple logic. Repeat the logic once again. So in the ammonia molecule, one of the sp3 hybrid orbital has a lone pair. Now the lone pair occupies the what? The lone pair occupies the most space, because the lone pair occupies the most space due to lone pair bond pair repulsions. Due to what? Lone pair bond pair repulsions. So the bond angle deviates from 109 degrees 28 minutes to 107. Simple logic. Now the provision in the logic. And go to next question. So explain the hybridization involving SF6 molecule. Yes, we take the example for atomic number 16. For 16, what you write? Neon 10. Okay, 3s1, 3px1, 3py1, 3pz1, 3d1, again 3d1. Here 3d as per the overlapping 3d x square y square 1, 3d z square 1. Now the sulfur you write in the second excited state. You get what? Sulfur in the second excited state you write like that. 3f1, 3px1, 3py1, 3pz1, 3d x square y square 1, 3d z1. Right, students? Very good. Now here, what happens? So in SF6 molecule, 1 SR dot, 3 PR dots, and 2 DR dots head-on combined. What I'm saying? 1 SR dot, 3 PR dots, and 2 DR dots are head-on combined and forms what? And forms 6 sp3d2 hybrid orbitals with the single electron each. With what? Single electron each. Understood? Now you get what? You get sp3d2 hybridization. Now what is the hybridization you got, students? You got sp3d2 hybridization like this. Is a sulfur having one of the sp3d2, one of the sp3d2, now one of the sp3d2, one of the sp3d2, one of the sp3d2, one of the sp3d2 having single electron each. All the hybridizers are similar shape and energy, and they are head-on overlapping with what? They are head-on overlapping with surrounding fluorine atoms. With the fluorine, in the fluorine, the 2pz electron is what? Single 2pz electron is available head-on overlapping and head-on overlapping and forms sigma 1, that is SF6. Diagrammatically, how can you show? Simple diagram you write is a octahedral geometry. Is a sulfur, fluorine, and fluorine. This is the 4 marks question. This is IPE 4 marks question. Maybe for the chemical bonding, one long answer, very short answers, 2 and 1 short answer. This is the one of the IPE 4 marks question. And remaining questions we see in tomorrow class. Thank you very much. Have any doubts? Please tell me, have any doubts, Nana? Clear what I am saying? So this is the complete explanation of what? Octahedral geometry. Here the bond angle is what? The bond angle is 90 between the bond pairs. So the geometry is called what? The geometry is called octahedral geometry. We write. What geometry you write? Octahedral geometry. Understood what I am saying? Right. Very good. So thank you very much.